Hey there, and welcome back to another Papetti Math YouTube video tutorial, where I'm going to be teaching you Algebra 1. Yes, you. And in exercise number 3, in equivalent exponential expressions, we're going to be looking at the cases where the bases may not always be the same. And in this case, you would have to determine an equivalent exponential expression that has the same base as your given information. So if we take a look at part A that's been completed for us, we see that we started off with 3 to the 8th is equal to 9 to the 2x. Now, we only know that the exponents are equivalent when the bases are the same. But in this case, the bases are not the same. And when we have a case where the bases are not the same, we want to look at each of these numbers and see if we could transform one of these bases into an equivalent exponential expression. So what I mean by that is this 9, we should know or recognize that 9 is a perfect square of 3. So I could rewrite the 9 as 3 squared, which is what I did in the first step. This is all exactly the same. 3 to the 8th is brought down. The 2x as the exponent is brought down. I only rewrote 9 as 3 to the second power, because 3 to the second power is the same thing as 9. So I haven't changed anything about this equation. Now that I have 3 to the second, to the 2x, I should recognize that this is a power of a power rule where I'm going to multiply these exponents together. So simplifying that, I get 3 to the 8th is equal to 3 to the 4x. 2 times 2x would give me 4x. And now I have the same basis of 3, so I could set 8 equal to 4x, divide both sides by 4, and I would get x is equal to 2. And that would make those two expressions equivalent to one another when the x value is 2. So now part B is not done for us. So now we have to do that on our own. So let's take a look. We have 125 to the x plus 2 is equal to 5 to the 2 times x plus 5. And again, these are not the same bases, so we want to think to ourselves, is there a way to change one of these to get an equivalent exponential expression of the other? And 125 actually can be written as 5 to a power. Well, 5 times 5 is 25, and 25 times 5 is 125. So that's 5 to the 1, 2, 3. So 5 to the third power is the same thing as 125. So I can rewrite that as 5 to the third. And I'll bring down my x plus 2, and I'll bring down everything over here as well. Okay, now I have 3 times x plus 2. So I can simplify this by distributing the 3 to each thing inside the x plus 2 expression. So I'm going to get 5 to the 3x plus 6 is equal to, and I could distribute this 2 as well, 5 to the 2x plus 10. And now that I have the same base, you betcha, I could cancel out the bases and be left with 3x plus 6 is equal to 2x plus 10. Now I have a multi-step equation, which we should be experts at solving at this point in the year of algebra. So we're going to be subtracting 6 from both sides to get all of our constants on one side. I'll be left with 3x is equal to 2x plus 4. I'm going to move all of my variables, in this case x's, to the same side of the equation, and I'll be left with x is equal to 4. So the value of x that makes these two expressions equivalent to each other is 4. And now finally, I have 4 to the 14th x is equal to 64 to the 28th power. So now what I want to do is I want to look at these and I want to think, is there a way I could write, I always like to look at the larger number. And in this case, the larger number is 64. And can I write 64 as 4 to a power? Well, let's see. 4 times 4 is 16. 16 times 4 is 64. So 4 to the third power is, in fact, 64. So I can rewrite 64 as 4 to the third to the 28th. And then I'll have 4 to the 14th x power. So now I have 4 to the 14x and 4 to the 3 times 28, or to the 28th, which tells me power of a power. So it's to multiply 3 times 28, and I get 84. So this is 4 to the 84th power is equal to 4 to the 14x power. Now that I have the same bases, I could set 14x is equal to 84. Bases cancel out. And I will divide by 14, and 84 divided by 14 will give me an x value of 6. So in this example, the x value of 6 would make these two expressions equivalent. And again, if you want to check that out, substitute x in, and you'll get 4 to the 14 times 6 is going to be the same value. It's a very, very large value. Your calculator might not even be capable of putting that into the calculator, which is why we use this method of solving, because we can find the value there even dealing with super large numbers. And that's what we're going to be doing by solving exponential functions in this chapter, is dealing with very, very large and very, very small values. So in this video, we have to change the base of some numbers. And if this video was helpful in helping you do so, to find the value of x, changing the bases of some of these numbers, or powers for that matter, please give it a thumbs up. And you're now ready for exercise number 4. Thank you for watching.